Hey guys, for this video I'll be going over mole conversion, okay, and this is part of our notes that we did in class. I'll be going over problems 1 and 2. Okay, so if you want to follow along for number 1, and you can try number 2 on your own, if this is your first time watching this video. But completing 1 and 2, you should be able to do these problems after watching this video. Okay. So when we do these problems, we're going to round to the nearest 10th place. That means we're going to round to just that 1 decimal place. But for now, I'm not too strict on that. But just to keep consistency, we're going to round to that 1 decimal place. Okay. So the first problem we have here, and I have to zoom in because the tablet is really small. Okay. All right. So number 1, our first piece of information they give us is 1.5 times 10 to the 25 molecules of NaCl. Okay, and ask us to find moles. So first of all, let's plug in that information that we have. They give us molecules. Okay, molecules is actually part of your particles right here. This top box. Okay, so that's where we're going to place that number. We're going to place 1.50 times 10 to the 25th right there. Okay. Then, right, they're asking you to go from molecules down to moles. You notice that blue arrow I'm drawing is going opposite that red arrow. Okay, whenever they go against each other, we're going to divide. The next question, you're like, well, what am I going to divide by? Okay, if you look at your mole map, right, the number right next to that arrow is Avogadro's number, or the mole number, which is equal to 6.02 times 10 to the 23. Okay, try to get this inside your little box. It's just difficult to type here, sorry, to draw here with the tablet. So now you have these two numbers that we're going to divide. Okay, so let me rewrite this on top here. We can do 1.50 times 10 to the 25th divided by 6.02 times 10 to the 23. Okay. When you put this in your calculator, make sure you put this in parentheses always. So then you get something, a number that's too crazy. Okay. Make sure you put the correct exponents for bottom and top. Okay. Once you put that in the calculator, you're dividing 1.50 times 10 to the 25th divided by Avogadro's number. You should get 24.9 moles. And this is a rounded number. This is the final rounded number. Okay. Once you find moles, you're in the clear. You want to find the moles. So from now on, we can use that number to calculate B and C. Okay. So let me erase this. 24.9. So our info was, oops, so follow along. I'm going to move up a little bit right here. So now we're in liters. Okay. Alright. So for liters, we already have our moles, 24.9 moles. Remember from our previous example. And we want to go to liters. Notice I'm starting from moles down to liters. Notice I draw my arrow. Always draw the arrow so you don't get lost. From moles to liters, I'm going with the arrow. Notice I'm going the same direction as that red arrow. So I'm going to multiply. And again, the question you have to ask yourself is, what am I going to multiply by? Okay. You always multiply or divide by whatever number is next to your arrow on the mole map, which is, in this case, 22.4. Okay, that is always going to be 22.4. That number is always going to be there. So all you have to do now is multiply 24.9 and 22.4. Okay. And when we do that, round it off, you should get 557.8 liters. Okay, round it to that 1 decimal. Okay. Next problem. The next problem requires a little more work, okay, but we still keep our moles, which is 24.9. Right? Once we found moles, we can use them for all the other calculations. And they want us to go to grams. So notice I'm going down to grams. I'm going with the arrow, so that means I'm going to multiply. And then you're like, well, what do I multiply by? Okay, whatever's next to your arrow. On your mole map, on this side of that arrow, is your molar mass. Okay. Remember, to calculate molar mass, you take your formula, which we had NaCl. That was our formula. Okay. To find the molar mass, remember you have to count the atoms and multiply by its molar mass. So, for example, sodium, we only have one atom of sodium, so we multiply that by the molar mass. And for our problems, I round the molar mass to make it easier on us. So Na rounded to 23 grams from the periodic table. So 1 times 23 is 23 grams. And then chlorine, you only have one atom of chlorine times the mass rounded is 35.5 grams, which equals 35.5 grams. Okay, when we add these two together, you should get 58.5. Remember, the unit for molar mass is grams per mole. Okay, so that number goes here, 58.5 grams per mole. The reason, always put that grams per mole. Okay, do not put these 58.5, do not put that number as grams. This is not grams. This number is not grams. That's molar mass. Okay? So do not put that as your answer for grams. Our answer for grams is 24 moles multiplied by the molar mass, which is 58.5. Okay? So 24 times 58.5, you multiply those, because we're going with zero, and you should get a big number. And for our answer here, we get 1,456.65, which I round to 0.7. That's our answer in grams. Okay. Alright. Okay. So it's problem for number 1. Okay, at this point, you can try number 2 on your own. Pause the video and then you can go back to it. But I'm going to work number 2 just so we can go along with this. Okay. So let's see. They give us moles. So this one, we're starting with moles, which is great because from moles we can go anywhere. We can go to particles, we can go to grams, or we can go to liters. Okay. So let's see, moles, okay. And they want us to go to liters. So automatically, as I go through the map, I can start 3.3 moles. Great. So and they want us to go from moles to liters. So always draw your arrow. So moles to liters. Notice I'm going the same way as my arrow. So that means that I'm going to multiply. What am I going to multiply this with? Remember, right next to that arrow is always going to be that same number to find liters. It's going to be 22.4. Okay. We're going to multiply 3.3 times 22.4. Okay, that number is always going to be there, 22.4. So when we multiply those two numbers and we round, you should get 73.9. So make sure you're getting that as you're following along with these calculations. So 73.9 liters. Okay. Alright. So I'll keep that information there. I think it can fit the next in here. Okay, the next piece of information, they want me to find the formula unit. Okay, so this one a lot of people are having trouble with because they don't know where to find that formula unit. You don't see it. Okay, so first of all, you can't put in moles because we already have moles, remember? This was given to us up here, 3.3 moles. And it's not liters because we just calculated liters. It's not grams, otherwise it would say grams. So the only thing left is particles. That's what they're looking for. That's what they're asking you for. Remember, particles can be a formula unit, it can be molecules, or it could be atoms. So what is that, right? So in order to go from moles to particles, notice I'm going with the arrow, so that means I'm going to multiply. And again, you're going to ask yourself, what number do I multiply with? Check your little map. Right next to that arrow should be a number that's always going to be there. And that number is, I forgot this number, should be 6.02 times 10 to the 23. Parentheses. Okay, so when you put that in your calculator, always put it in parentheses. If you don't, then you get some, different answer. So we multiply 3.3 times 6.02 times 10 to the 23. Okay, you should get 2, round it off, you should get 2.0 times 10 to the 24. Okay, if you, on the calculator, you're using the e function where you put second comma. So if you're using e, for example, let's say your answer, let me calculate this real fast. If you were to put this in your calculator, 6.02 times 10 to the 23 times 3.3, and you were using the e function, you got something like 1.988 or 1.9866 E24. Okay, you got this. Alright, so that's what you get, and I rounded it to 2.0 times 10 to the 24. That E is telling me that's an exponent, and the exponent is 24. Okay, so don't put this as your final answer. That's not correct. Okay, we really need you to write it in scientific notation. Okay, because you're always going to see your answers that way. Okay. So make sure you're double checking on that. Okay. Let me erase this info. Okay. So now the last thing to look for is graphs. Remember, they gave us moles already, so I have that information here already. So I'm good. And they want me to go from moles to grams. Moles to grams. Notice I'm going the same way as the arrows. I'm going to multiply. What am I going to multiply? What's right next to that arrow? What's right here? Check your molar mass. It should be the molar mass. So now we have to do the work and find the molar mass of magnesium hydroxide. This right here. Okay. So let me take that step by step so you remember how to do that. Magnesium. How many atoms of magnesium do I have? I have 1 and multiplied by its mass, which is magnesium is in group 2. Looking at a periodic table, rounded is 24.3. And 1 times that number is just that number. And then oxygen, so here's where a lot of people mess up. Okay. Remember, oxygen is in parentheses and there's a 2 right outside. Meaning that you actually don't have 1, you actually have 2 oxygen. 2 times 16.0, that's a mass rounded, which just gives me 32. It should be grams. It should be grams. Forgot to put that. And then hydrogen, there's 1 inside the parentheses, but remember that 2 is going to kind of distribute to it. So 2 times 1.0 grams on the periodic table is just 2 grams. When we add these up, you should get 58.3 grams per mole. Okay. Make sure you do not put that number as your gram. That is not grams. This is molar mass. So you put that number here, 58.3. Okay. So you multiply 3.3 times 58.3 grams per mole. And for our final answer, you should have gotten 192.4